Hi everyone. Sorry I brought some bad weather with me, even though in Bulgaria it was hotter than here, obviously. Um, so I don't know how much time I have, but I think I did this presentation a bit too long, but we can adjust it. So I'm also comfortable if you want to talk about something here in a bit more detail or ask questions, please interrupt me. I'll first say only a couple of words about semantic technologies, then describe onto text briefly, describe some of the products of onto text that are relevant to the topic, and then I'll go. The majority of my presentation is on projects in the culture heritage or GLAM domain that we have been involved with. Um, this last project is quite important for me, the Getty linked open data, and I think I'll switch there to another presentation because I didn't have time to put it in this format. So, semantic technologies, some people say that this is Web 3, if Web 1 is about hyperlinked documents and if Web 2 is about applications and social involvement, Web 3 is about interlinked data. And how new is that? Well, it turns out that it's not new at all. I mean, even in the very first original proposals of Tim Berners-Lee about the web, you can see a lot of what comes out as the semantic web. So he didn't talk only about interconnecting documents, but also about interconnecting people, information about other things like printers, resources, document storages, libraries, archives. Um, this is very similar to the domain of graph databases, but the difference with semantic technologies or RDF based stuff is that it is standardized by the W3C. There's a standard querying language, Sparko. There's ways to define inferencing, RDFS and OWL and RIF. And it does come up quite often recently with buzzwords like big data, semantic analytics, text analytics. There's especially text analytics has really been booming. There's maybe over 50 companies now that do that to one or another degree. So here are a few examples of linked open data. So this is data that is represented in this format and also interconnected. The basic idea of RDF is that you represent everything using URLs or URIs, whatever you want to call them. So every piece of information inside a dataset should have its own URL. You're not limiting yourself to just primary keys in a database, but then the information, what does this mean and whose database it is and so on, would be interlocked in a data model or in somebody's head. So maybe you've heard about the link open data cloud diagram. Actually, this is a version from already 5.5 years old, so it is at least 10 times bigger by now. And here in red and orange are two public services that OntoText provides. We call them RDF warehouses, or a reasonable view over the web of data. This basically is an aggregation of the datasets that are outlined there. So I will have a bit more information about FactForge, which is the red pieces, and Link Live Data, which is the orange pieces, later on in the presentation. Basically about the size of those. Link Live Data is used quite often by pharmaceutical companies in their drug research. So it's information about genes, path interactions, illnesses, anatomy, medline publications, you name it, it's basically there. Another example is an area that's fairly hot right now, linguistic linked data. So the question here is how can you represent the entries in a dictionary, for example, with the part of speech annotations, with if you have a corpus or a sample text, also to tie up back to the dictionary definitions, and also to tie up to other linked open data. So for example, if you have a sentence about Malmö, uh, you should be able to interconnect the DBpedia or Wikipedia entry of Malmö with that word in the sentence. And cultural heritage also is starting to have its linked open data cloud. But what you see here is basically only thesaurus information. So lists of concepts, people, places, and so on, subjects, iconography. And we're currently working with these datasets of the Getty Trust. I'll talk about them at the end of my presentation. They actually have 4 thesauri. The 4th one is the most interesting one, Kona. It is a data set about works of art, whereas the other ones, the 80, and this is old, it has 45,000 concepts now. 80 stands for Art and Architecture Thesaurus, and it's a big thesaurus of subjects of works, materials, colors, painting, and so on and so forth. Okay, so in the cultural heritage domain, I think it's the application of semantic technology is very appropriate because the data there is fairly complex. There's no strong standardization of the data, probably because of that complexity. There's various standards like Lido, for example, or the Getty CDWA, or CDWA Lite, and so on. But when museums and other institutions represent their data as linked open data, then the benefits of interconnection become very important and visible. And you see examples of this in some of the projects that I will describe. Europeana, which I am certain most of you have heard about, have published that to quite a strong degree. Even though if you look deep into Europeana, it's not very semantic at all. It uses an RDF format for gathering their data, the EDM, Europeana data format, but then only now we are working with them to use that in a semantic repository. Until now they are based basically on Solr, faceted search using Solr, and therefore the ways that you can query these data are limited to their predefined query patterns in a sense. Well, Europeana is the pan-European virtual museum and library and so on, with about 33 million objects now. And Europeana will become a CEF, Connecting Europe facility, I guess. So CEF is a line of funding to enable interconnections between countries at the European level, in transport, telecommunications, and now also in cultural heritage. So from one of the Europeana projects, I saw a semantic technology mind map. So these are different areas of semantic technologies that Europeana have outlined. And I'll just zoom in on one small piece of it. So if we're talking about controlled vocabularies and thesauri, they say that this has been addressed in several Europeana related projects. So for example, Europeana Connect, Europeana Local, Athena, EFG is the European Film Gateway, and so on. And here they say, well, this is the tasks or the deliverables that have been touching upon this subject. And one problem with European projects in general is not sufficient reuse between projects and not sufficient accumulation of the work. I mean, a project is over and then what happens to the developed software is most often is just left behind. Okay, now about OnToText. OnToText has been working in this area since 2000, but it was spun off as a separate company in 2008. We have about 75 people. All of our development is in Bulgaria, and we have now 3 or 4 people in the US doing marketing and sales with some grand ideas. Of course, the first thing is they throw away the old website and put a new website. Half the content is still missing, but and yeah, we have quite a number of projects on a global scale, spanning from Korea to also in Sweden with AstraZeneca. Most of our clients currently are in the UK, but we're hoping to expand more in the US market as well. I think that OnToText was one of the first companies to make serious business out of semantic technologies. So we have some very high profile deployments. I think the first one was with the BBC, and this is also the strongest, hold on, just let me plug in. So the BBC represents the strongest vertical that we currently have, which is in publishing. This includes mass media, but also technical publishers and educational publishers. There's another slide with a list of clients. So actually you see here some of the names. Interestingly, also in financial information, so Euromoney is a very big publisher of financial and investment information. It's part of the Daily Mail group, and Financial Times everyone knows. We've also tried to do a bit with FIBO, which is a new initiative out of the US to try and interlink and standardize accounting information. Basically, after the crisis, they're fed up with everyone doing their own gap, in a sense, their own version of the rules. So they want to have interlinked information, also to be able to find networks of companies, cross holdings, and so on and so forth. The second strongest vertical we have is in the life sciences industries, basically large pharmaceutical companies. So this data that I showed is very useful to them when they do drug research, and we make very powerful and semantic and flexible semantic search solutions for them. So basically the story is that when you have to do clinical trials for a new drug and you have 100,000 other trials and all of their documentation, which is in the tens of millions in maybe 100 locations worldwide, how do you find the documents that your company has already produced to save you the need to run particular tests again? And each one of these tests, it starts from 1 million or 2, because I mean, you have to select a group of people. Very often they have to be in different countries because you need to address different races and so on. You need to contract doctors in these countries, and I mean, the expense is really big. So it's easy to justify these technologies in life sciences. Some of our clients on the first and second line are publishing companies. So you see, for example, from mass media like the BBC to press associations, in other words, organizations that either create content or gather it for newspapers or other media to be able to use it. So a good example is NDP, which is the Dutch Press Association. Quite curiously, 20 newspapers there decided to pull together money and to invest in a semantic search platform. Concept extraction, semantic annotation, and semantic search. And it's curious because they are strong competitors in the marketplace, but at the same time they see this as a good IT investment for everyone to benefit from. Before the talk here, I talked with a person from a company that works with television stuff. So, for example, Korea Telecom, we were partners in a project called NoTube for interactive television, and this was the application that we have for them. Which languages? We have experience with English is of course the biggest language that we deal with. Italian, Chinese, German, but no. For this we provided the semantic database, but none of the language handling. There's a fairly strong company in Korea called Soutlooks that deals with semantic technologies and annotation. So we have some clients in the government. The Food and Agriculture Organization, for example, uses our semantic database. And here this row is some of our culture heritage clients. The Göteborg Museum, for example, this was part of an European research project called MOLTO, and there we represented museum data in a semantic way, and we did generation of text out of semantic data and also translation of text into Sparkle queries. But of course this was controlled natural language, so you cannot ask it any random thing. It has to be in a specific, stated in a specific way. And I'll talk about most of this. I'll just mention this. This is the logo of the Polish National Digital Library. So they have about an aggregation of about 3.5 million museum artifacts, library books, recordings, and whatever. And they also use our semantic database. OnToText is very strong in European research projects, and for the first maybe 4 or 5 years of its existence, that was the main volume of work that OnToText did. But around 2007, 2008, we started decreasing the European projects and went a lot more after commercial projects. As you see, it's a nice pipeline of projects with overlap between them, and a lot of these projects allow us to develop stuff that we want to develop. For example, the semantic database, this life science aggregation of data sets, and so on. And I'll talk about the current projects on the next slide, so it's like about 5 or 6. Interestingly, in Bulgaria, OnToText is the strongest participant in these projects, more than any of the universities and so on. About a third of the projects in FP7. So some of the current projects, Euclid is about creating learning materials for linked data, so you can check out their website. They have very, I'll put this on after I finish it in a couple of days. It's on GitHub, and we'll put the link here on Fucafe, so you should be able to access it. So they have a complete course about how you can represent your data in linked open data, how you can then implement an application on top of it, and so on. Anno Market is about the creation of a marketplace for semantic annotation software and also language resources. So the one big problem is that in the NLP area, there's a very big segmentation and fragmentation of different software, different approaches, different language resources, and the coverage varies very much between languages. For the major languages, you can find pretty much anything. Post-tagger, stop word list, syntactic annotation, but for the smaller languages, there's no such data. And the European Commission is recognizing this, so now in the first call of Horizon 2020, they had a specific call for the smaller languages. The Linked Data Benchmarking Council is an interesting project because in there we partner with 2 of our competitors. One is OpenLink, that also make a semantic repository, and the other one is Neo4j, which make a graph database. So this project is about creating meaningful benchmarks following industry relevant use cases. And we there are developing the benchmark of semantic publishing, inspired by the BBC data and cases. These 2 are right on into cultural heritage. Europeana Creative is a project that tries to take data out of Europeana and do interesting applications with it. I'll have more details about it later on. And the role of OnToText in this project is core technological partner. So we are doing semantic repository and SPARQL endpoint for the Europeana data, and also implementing an OAI server so that anyone can get all of the Europeana data out. Currently you can query for data and look at it and get single records, but for the repository we need to be able in batch to get all of the records. Europeana Food and Drink is a relatively recent project for pulling together information about cultural artifacts that have to do with food and drink, so naturemorts or poems or recipes. OnToText will be contributing Bulgarian recipes and implementing semantic application with all of the content, also helping the other partners represent their content in an appropriate way. And we're also working on a food classification scheme, basically getting out of Wikipedia and DBpedia the categories that have to do with food and figuring out what are the superclasses of, let's say, aioli or chipotle. Um, and these last three projects, multi-sensor, I'm involved in this one. It's about content analytics. So um, you can start either from articles, or one of the use case partners is a company called Press Relations out of Germany. So what they do is a press clipping service for either specific topics or for specific companies. And multi-sensor will allow companies like that to do it in a better way. So maybe there's 50 different ways to spell the name of your company, or there's a classification of the industry in which you're working in, and you want to find articles about new topics in this area or competitors. Well, semantic technologies allow you to do that. DAPAS is software to create data marketplaces and open data portals, which is something that is becoming, I think, very important now, because many governments, they have a mandate to publish their data in a good way. And I heard that Mamio has a project about this right now. There's also two current tenders from the European Commission about that. Interestingly, the European Commission is developing two open data portals at the same time. Theme is about finding out whether a certain tweet is true or not, and finding out whether an event that is described by a bunch of tweets is true or not. I don't know how they do it. I'm not even. Okay, now in the next section I'll talk about some of our products. Aulim was the name of our semantic repository. Now it's called GraphDB since about a month. It's one of maybe 4 or 5 commercial semantic repositories. For example, Oracle has one, but Oracle is not used very often, because the way that you store graph data or RDF data is very different from the way that you store relational data. So there's different techniques and optimizations and so on. Well, Aulim supports the two important Java frameworks for working with RDF, which are called Jena and Sesame. It's built on top of Sesame, and we are the largest commercial contributor to Sesame, which is open source software. Because it's important for us, because it's a foundation of ours. So, for example, we implemented all of the Sparkle 1.1 support in Sesame and things like that. And it has found quite a good following in the cultural heritage domain. I'll have a list of deployments a bit later on. Perhaps one of the most important features of GraphDB is the reasoning that it supports. So you can do 2 of the 3 profiles of OWL2. It also, of course, does RDFS. OWL-Horst is something that people call RDFS plus. So anyway, these are different levels of reasoning with, of course, different complexities and different number of inferences that can be inferred out of them. But also importantly, you can put your own rules. So I'll show you an example of that for work that we did for the British Museum, which, by the way, is described on these brochures. I've put some brochures over there. So it is within the research space project, something called CDOC CRM Search. The other important feature in GraphDB is fast. In addition to fast inferencing, there's also fast retraction of statements. So people take it for granted that in a database you should be able to add and you should be able to remove quickly. But there's few, if any, repositories that allow you to do that. Because when you remove a statement, you also need to take care of all the inferences of that statement. Aulim is, or GraphDB is a forward chaining repository, which means that it records all of the inferences of a given statement plus the ontologies. And in this situation, you need to be able to find and remove all of the consequences of a statement that is being removed. whereas most other repositories, they don't give you this level of reasoning at all, or you have to do tricks and whatever to go around it. Some new features of GraphDB in this latest version 6. So we have an enterprise version, actually, that has been for last 3 years or so, that allows you to cluster for higher performance, and people like the BBC use this very heavily. The BBC have a cluster that is spread in different data centers, so that even if you have a shutdown in one of the data centers, they continue to serve. And the latest thing that we're working on now is connectors. In other words, things that are much faster to do in other software. For example, for faceting, well, people use Solr and Elasticsearch, and they're very, very well tuned for this kind of application. And the connectors allow you to synchronize semantic data basically for every new statement. If you have set how facet should be inferred out of that or taken out, it puts that in the external system. The KIM platform is the name of our platform for semantic annotation and search. And the way it works is that you first describe what you want to annotate or capture or extract out of text, the annotation guidelines, and then you, or with our help, we create a gold standard corpus, meaning that manually we go and we annotate different instances of documents. And then we employ machine learning techniques over that. As background information, we always use semantic knowledge base. So we first assemble a knowledge base of the important topics and instances in a particular domain. I'll say a bit more when I describe the project for the UK National Archives. And the different extraction techniques that we use, they involve named entity recognition, which also includes semantic disambiguation. So these machine learned models, they're probabilistic. A good example is from the BBC. The first time when it hits the name Athens Olympics, it says, well, I know about 2 Athens Olympics. The one in, I don't know, 2004, when they spent a lot of money. And there's the original one in 1876 or so. But after a journalist says, well, I mean the new one, the recent one, then the probabilities of these two, of the words Athens Olympics meaning one or the other entity, are adjusted. And so there's a feedback loop, a human-computer interaction, if you will. In other words, every human action we try to leverage by adjusting the machine learned model so that the next user would not have to say the same thing again. This here is a link to something on our website called Semantic Solution. So it's a set of architecture or customization documents describing how you can do different things with KIM and where are the points where you can plug in your own stuff and so on. So you see here some of the different components, if you will, or things that you can customize. For example, well, loading documents means that you feed documents into KIM, and we usually do this on a cloud infrastructure. And the documents are processed, first of all, to extract the text. So if it's PDF, then a certain component is added. After the text is extracted, then it undergoes automatic semantic annotation. KIM is built on top of Gate out of the University of Sheffield, which is probably the strongest text analysis toolkit. Gate is not about semantic annotation, it's about any sort of text analysis, an NLP toolkit. Okay. And the third product that is not yet, I mean, we're selling it already, but it's not yet kind of packaged or described or publicized. So this is what the big publishers use, different components and their interconnection to be able to do semantic annotation over their journalistic content, or if they're a technical publisher, for example, over papers, over articles. And it's a large set of components that includes both automatic but also manual processing, adjusting of things, generating recommendations for particular users. So after knowing what the user is interested in, and because we know in quite a lot of detail what the document is about, then we can do quite good recommendations for the user. And finally, we are also maintaining an ontology called Proton, which is often used as the underlying ontology for these semantic deployments, but not always. Yeah, you can find also information about the different verticals that we work in, such as this brochure, for example, you could download from here, but there's also another brochure in life sciences. We have a web mining framework that I haven't even mentioned. So how can you get information out of websites? A good example is in the UK we have a data product for job postings. So we crawl over 200,000 company sites, get the job postings out of there, classify them, and then you can do very interesting searches over them. So this here, the heading is a link to this page where you can get more brochures and so on. Okay, now I'll talk about cultural heritage projects, and I need to speed up. The first one that we were involved with, this was about 3 years ago with the UK National Archives. So the task there was to do something meaningful with the web archive of the UK government. They have a whole department at the National Archives called Web Continuity, and what they do is they archive every government website periodically. But the question is, what can you do with it? So basically we took all of those documents, 700 million. So you can see, basically I'm giving this as an example of extreme scale processing. Not that the processing involved was very interesting, but the scale was very, very large. Then we assembled for them the knowledge base according to the UK government ontology. So this basically means everything that the government works with, different lines of business, the structure of the government, how it varies over time, who holds what office, everything, taxonomies and so on. And then we did automatic document classification, extraction of entities, and a semantic search platform on top of that. Europeana Creative, I mentioned it in the beginning. It's a project to try and use Europeana data for the creative industries. This is basically it was quite interesting for me because I don't consider myself a creative person. I consider myself a meticulous person, digging deep into the details. But yeah, it involved a lot of workshops, brainstorming, trying to figure out what you could do in a particular domain. And this is basically the flow of work that they're following in 6 different applications. I'll show them on the next slide. So they have also open challenges in those domains where we help companies that are selected. So basically you come up with an idea, and if you're selected, the technological partners help the company to work with the different Europeana APIs. And there's also business partners that try to help them to make some idea of how they could make money with that software. The different areas that the project addresses are tourism, social networks, design, natural history education or biodiversity, and history education. We're involved in the second one on social networks with the Dutch Institute of Sound and Vision and the British Library, which provides some sounds that we help to put on a map that then the company History Pin takes and puts on their platform. Quite interesting. Within Europeana Creative, our role is mostly on core technological stuff, on backend technologies, and we're helping Europeana to fulfill three of their stated key performance indicators in the technological area. So we are doing an OIPMH server so that others can get all of the data from Europeana in book, putting the Europeana data in a semantic repository, and providing Sparkle querying over it. Also in the project we do geographic enrichment, so finding out place names and things like this in Europeana records. We have two endpoints. The first one, Europeana.text.com, is about 1.5 years old. The second one, Europeana test, it is current, but it also doesn't have all of the 33 million objects. It has about 20 million because we are still trying to finish this OI server to get all of the data out of Europeana. So this is work in progress. Here's an example of a query. In this case, finding periodicals out of Polish digital libraries and showing them by year. So they have papers from the 1400 all the way, of course, to 2014 out of three digital libraries in Poland.
When you run a query like that, what would be the response time of that, roughly?
It depends on the query. Also, it depends on the size. Let's see. So it's getting all of those and then grouping them by basically the library they came from. And well, because the result set here is not very big, I think this was like 35,000 records. So I'd say a couple of seconds. But of course, if you need to count and group by attributes of, let's say, 5 out of 30 million objects, it will be quite slow. Here you can see an example of an object in the EDM format, Europeana Data Model format. So in the middle is the object, on the left side is information that came from the provider of the object, on the right side is information that Europeana additionally deduced. And you have a proxy and you have an aggregation, and basically my job as working in this data and ontology management group is to deal with graphs like that every day, different ontologies and different interconnections between things. In Europeana Food and Drink, I mentioned that we're working on a classification scheme for food and also for cultural things related to food. So for example, which festival is this food related to? In which regions? When people started making this food in these particular regions? Also variations between foods and stuff like that. Semantic representation and storage, so GraphDB will be used in this project. Text analysis using KIM, and finally we have to make a semantic application using this data. Still have no clue what it's going to do, but the reason I think we got into the project, one of the reasons, is we did work for a US startup called Edamam on web crawling of recipes and then recognition of the ingredients against, for example, the US Department of Agriculture standard reference, extracting nutrition information, and then you can search by different things. For example, low fat diet, low sodium diet, or kosher food, or give me food that's appropriate for kids or easy to make. So we're trying to calculate the preparation time. Of course, all of these tasks are quite hard and the results are approximate because people write recipes every other way. I mean, I worked on the ingredients and the measures, and you won't believe what people write. For example, ingredient, well, any green vegetables you have in the fridge, or quantity, well, drippings after roasting that piece of meat. So whatever drips out, you use it. But how much is that? It affects the calories.
Did you say that you are trying to figure out the time for preparation?
That is, Well, the time is stated, but you don't know which of those things overlap. So you could you could
Could you just from the ingredients calculate what would be the
no
time?
you no you can't. Yeah, but there's hard enough problems for the ingredients. I mean, how much is a pinch of salt, and what's the difference in weight between onion chopped versus onion grated? There is a difference, yeah, because the how do you call it, the relative weight per volume is different. We're also trying to do some stuff in Bulgaria. So we have something called Bulgariana, an aggregator to Europeana, which is very hard because there's no funding in Bulgaria, and also because the museums are still quite backwards. We've heard them say we don't want to put this on our website because people then will not come and visit the museum. But we published a few collections. One was very interesting and important, Thracian gold treasures and sacred places. And it ended up in the first mobile application of European. Well, somebody created the first mobile for an iPad application, and it was featured there, so that was quite nice. These are different deployments of GraphDB in cultural heritage. So the British Museum dataset, I'll talk about this later. The Polish Digital Library I mentioned, Europeana. Getty I'll describe at the end of the presentation. Then FactForge and LinkLive data I mentioned, and I'll just provide the numbers on the next slide just for comparison. A Japanese linked open data project called lot.ac, LODAC, and a couple of European projects. Charisma is about conservation data. So that was quite interesting because we also participated, similarly to Research Space, there's another project called Conservation Space, also funded by the same organization, the Andrew Mellon Foundation. So it turns out that conservation is another very interesting topic and good community there. So these are just some statistics about a few of these data sets. So for example, the British Museum data is represented in the CDOC CRM ontology. I won't have time to say anything about it, but I'll just say that it is quite a good fundamental approach to representing historic and archaeological and cultural information, because it's based on certain good philosophical principles. So, for example, you don't state things, you don't state the attributes of things directly, you usually go through events. You cannot say the date of birth of somebody. You have to have the event of birth, and that's where you have a date. You don't say date of birth, you just say the date of the event of birth. So all of this is in millions. So the British Museum had 2 million museum objects, which took 4.7 billion, which took 916 million total statements, of which 195 million are explicit statements and the rest is inferenced. So the expansion ratio in the case of the British Museum is 4.7. For every statement you infer about 4 more. And well, if you compare this, for example, to the link live data dataset, you see that these are moderate sizes. So this is 10 billion statements. But of course, the reason here is that these are some of them are single institution sites. Europeana is different, it's an aggregation, but Europeana, because it's represented in the EDM, which is a Flutter model, has only 50 statements per object, as opposed to 90 for the British Museum. Anyway, so you see that the strength of OnToText is in working with large data sets, doing inferencing over them, semantic search, and text analysis also. This British Museum linked open data and SPARQL endpoint was created as part of the Research Space project funded by the Mellon Foundation. And I'll have a few screenshots from it in the following slides. Basically, it's a virtual research environment for art research. So a way of interconnecting art data together and doing text annotation, image annotation. This is described in a few papers. I have here made links to some more presentations and videos by people at the British Museum. So Dominic Oldman is their IT boss, and Barry Norton, he used to be with TextOnText, and he joined the British Museum about half a year ago, I should say. So what I can say about the CDOC CRM in particular and cultural heritage in more general is that there's a lot of interaction in this domain between the different people. For example, this here presentation was at the National Gallery of Art, who they host the conservation space project. This was at the Rice Museum. Holland, by the way, is very strong in this, probably the strongest in the world, especially in cultural heritage. Europeana is also hosted at the National Library, Holland. So this is just a screenshot from the British Museum linked open data endpoint. Of course, the real strength is that you can make queries using SPARQL, but we have a simple UI over it. So, well, it was interesting for me. I checked out the different materials of this sculpture from the, well, you know, these very popular sculptures, and it was interesting for me that, okay, it says it's made from basalt and some other kind of stone, but also coral. This third material was coral. So you can search, for example, give me all of the things that are made of coral and have a particular topic. And this is actually this too, Semantic Search. I'll have a more technical description of it a bit later on. But basically we try to make it as a natural language thing, but it's controlled. So when you type Rembrandt, it will ask you to autocomplete from an entry from a thesaurus. After that, because it knows that it's a person, so you can only pick a certain set of relations that it can be by Rembrandt or it can be about Rembrandt and a few more. And here's you can enter the type of thing that you're looking for and the subject topic of the thing. And you see that because the British Museum thesaurus is hierarchically structured, I'm searching for mammal, but I'm finding paintings of more specific things like horses and pigs and so on. This also works across museum collections. So, for example, the Yale Center for British Art, they also were very keen to be able to interconnect their data against the British Museum, because for certain painting, maybe the British Museum has the initial draft and Yale Center for British Art has the final painting, or the influences between painters could be stored in the different collections. And this is semantic data annotation. So about any one of the statements of the object, let's say what is it made of or when was the creation date, you can add some more information. And there's like discussions of the cultural heritage specialists. This is image annotation. So you can, first of all, it works over deep zoom images. These are gigapixel images. So we use the deep zoom server. You can go as deep as the underlying photograph. And you can make vector graphics over it using SVG edit. And then you can put semantic annotation about the area that you have outlined. The next topic is more technical. How did we implement this semantic search? So the thing is, when you represent some cultural heritage information in CDOC-CRM, you end up with a rather large network, and also there's different variants how things could be expressed. And the question is, how can a user find things in that network? And there's an approach called fundamental relations. Basically, the idea is that you collapse this very wide and broad network to a smaller set of fundamental relations that are useful for the search. So here's an example. If you want to define the fundamental relation, a thing is from a place. So in some way the thing is associated to the place, but it's not about the place. It was either found in the place or made in the place and so on. And all of these here bullets, they represent different alternatives that could contribute to this fundamental relation. So for example, this here branch, which is nested 3 levels, it could have been created, the creation of the thing could have been done by somebody who is born in a particular place. And then you'd say, yeah, this thing is from Italy. Or the creation of the thing itself took place in Italy. Maybe you don't know where the painter was born, but he worked all of his life in Italy, so that still qualifies. The stars here signify recursive part of relation. So if we take the person or the actor, maybe you don't have information about who exactly created it, but you have information that it was made in the workshop of Rembrandt. So that's a group. So you'd say, well, Rembrandt is a member of a group being the workshop of Rembrandt, and the creation was made by the workshop of Rembrandt. So the point is that wherever you see a star, you need to make a recursive kind of query. Now, I'll just switch to the network representing this. So all of these different branches that you saw, and the recursive is wherever you have a loop. So these are the different ways in which these people from Fort, and one of the main creators of CDOC-CRM is from Fort in Crete, have defined the fundamental relation thing from place. And the question is, how can you implement this? How can you make a query that will run fast enough? The first attempt, so this diagram is made on the basis of this rewording of the English definition. So this is the same definition as you saw in English, but done using CDOC-CRM classes. So for example, beginning of existence, this is an event that includes the creation of a group or the birth of a person. And the recursive link we follow is that, well, maybe somebody did not record the creation of the group atomically as one event, but as a series of sub-events. Because for some groups, let's say, I don't know, the United Nations, maybe you cannot say, well, the United Nations was formed on this particular day. It was a whole series of negotiations and events and so on. And so the first attempt to implement this was done with Sparkle in the 3D Coform project. You see the Sparkle query, and coming back to your question, well, this didn't work. This takes forever, especially if you remember on the screenshot, we're not just looking for things made by Rembrandt, but also things that are of a particular type. So we're conjoining several of these fundamental relations. And if you get a query like this and put 3 of them together, it's just never going to end. So the way we implemented it is by inference. This is a slightly corrected version of the network for this one fundamental relation, thing from place. And the way we implement it is by decomposing it in terms of parallel and sequential composition. So, for example, I can say that if I have relations that implement this and this and that, I can implement this one by saying, well, this is this or that, or itself. So the way that we implement OR in RDF is by subproperty. The way in which you can implement a sequence, so from here to here and then there, is a property chain axiom. Basically, we wrote a bunch of rules in Aulim to do the composition like this. And more recently, I have used a somewhat similar approach for the Getty project. So if you follow this here link, extending out to with new property constructs, it's still not a paper, but like a set of extra relations that I have found useful. This thing, of course, you cannot see anything on it, is the dependency diagram of the different relations that we define. So we implemented something like 19 that use about 60 original relations and some sub-relations. So some of these intermediate things, like the gray things, they are not useful to the user as an end product, but we have them as intermediate product to reuse. Okay, and finally, and I'll try to finish within 5 minutes, I'll talk about the Getty linked open data. And I have a couple slides here, and then I'll switch to another presentation that I had from before. So maybe you're familiar with the Getty Trust. They have 4 branches, and here we're talking the Getty Research Institute. The Getty Research Institute has done very, very nice work in the area of metadata for cultural heritage and thesauri. So they'll have several special presentations at the CDOC Congress in Dresden in September. We are also going with them there. They have 4 thesauri that are very well respected by the community. Well, the fourth one, Kona, is still quite new and doesn't have a lot of records, but these 3, AT, TGN, and Yulan, are quite well known and used. And about 1.5 years ago, Getty made a decision that they want to put all of this openly as linked open data. And we have been working with them since last August. So that's a whole year now on this area. So the Art and Architecture Thesaurus was opened in February. The Thesaurus of Geographic Names was opened just now. And we are then proceeding with the Yulan. Yulan should be finished hopefully by New Year. Then in the next year will be Kona. And also we'll be doing the Getty bibliography and some data from the Getty Museum, which is not as big as the British Museum, something like 260,000 objects, but it is also very well respected and important museum. As part of this work, we had to work with a number of technologies, including the newest ontology on thesauri, which is the ISO 25 something. So for the first time, the ISO Committee on Thesauri has made a distinction between broader generic, broader instantial, and broader partitive. And we helped them to iron out some bugs out of the ontology. And the Getty is the first application of that on an industrial scale. If you're interested, there's very, very detailed documentation of all of this at this address, 100 pages or so. The ontologies that we worked with, these 3 for describing thesauri. SCOS is pretty much the standard in this area. SCOS Excel allows you to give more information about labels. So when was a label recorded, when was it last changed, who contributed it, and so on. For sources and contributor information, we used BIBO, which is a bibliographic ontology, and FOF, friend of a friend, for people and organizations. We used Dublin Core and the Dublin Core terms for common stuff. For the TGN, for representing geographic information, we used the simple WGS, World Geodetic Survey, and schema.org. And we also used PROF for provenance or revision history information. So this is an overview of the representation of one object. The objects in Getty are called subjects or concepts, basically. So you have basic information about the subject, information about all of the labels of this subject, including historic info. So for example, put golf courses turns out to be a trademark of a certain company, so they record when was it in force and when is the end of the applicability of this term. This is also quite useful for place names, of course. Then you have scope notes, you have the sources. This is revision information both about the concepts and also about sources. These are associative relations between concepts, hierarchical relations going up. So quite a comprehensive representation. It's of course not the first time that the Getty vocabularies have been represented in as linked open data. Actually, there was a guy at the Free University Amsterdam who did his master thesis maybe 6-7 years ago on these topics. But Getty are very particular about representing the whole richness of the information and representing it the right way. These are more details about the thesaurus of geographic names and how we lay out the data there. This is one of the pages of the documentation of the ontology, so extra properties that we made. The majority of these are the associative relations between things. So for example, 2818 source 4 connects an material to the object from which this material is made. So let's say, I don't know, abalone shells and whatever. You have all of these useful relations between concepts. This is just too technical to go into. This is an architectural diagram about the linked open data site. So the data is stored in GraphDB or Aulim. Out of there we extract for every entity all of the information across this network that you saw, and we put it as an entity file. So if you go and find AAT/12345 you'll get all of the information about that concept, including all of its sub-objects. There's a full text search provided by our UI framework called Forest. The data comes from their editorial system, which is implemented in Oracle using R2RML conversion scripts. And finally, we... Yep.
Is that the standard relational database or something, the inputs?
There is a standard called R2RML by the W3C, which allows you to define the mapping from a relational database to semantic format.
I mean, yeah, typically when you have projects like this, you start from a relational database.
Well, that was in this case, but there's many other variants or cases. For example, I'm talking right now to a guy in Switzerland, and they want to set up something like the AAT, but for Switzerland. And they want to do it with a thesaurus management system that works directly over semantic repository.
And that is mainly done automatically from that, or do you have manual inputs all over here from the system?
The conversion is done very much manually by intellectual effort. I mean, the definition of how the conversion should proceed, and it is expressed in this R2RML language. And then there's a choice, a selection of software that implements that standard and can produce it. So basically, the process with Getty is that every 2 weeks they make a fresh extract out of their database. They generate all of the different. So for the AAT and for the TGN, they generate something like 10 files of different kinds of statements, which are then inserted into Aulim, which does inferencing in first more triples. Then a full text index is created for that, and a geo index for geographical queries. And then we also extract these, I call them entity files. So for every object, you should be able, when you resolve the URL, to get the semantic representation of that object using content negotiation. So this also is implemented, HTTP content negotiation.
Another question, the present DBpedia.
Yep.
To what extent is that done in a similar structure to this, automatically or semi-automatically from Wikipedia?
DBpedia extracts automatically out of Wikipedia, and the most recent development is DBpedia Live. I think they made it about 6 months ago. So this watches the minutely updates of Wikipedia and makes updates on the fly. It's a custom extraction process in their case, because the way that DBpedia works is they get information out of info boxes, out of the structured pieces of a page, which is maybe about 1-2% of the whole page. This thing on the right, called the info box. And also if you have a table of things in the page, it could also extract from there. And there's, I forget, maybe about 50,000 different types of info boxes implemented as Wikipedia templates. And there is a site called DBpedia Mappings, where people, again in a crowdsourced manner, define how every one of these info boxes should be mapped to what classes. Because very often you have gratuitous differences. So somebody makes an info box for an Austrian city in Austrian, for the Austrian Wikipedia, and another person makes the same thing for the English Wikipedia, and they map to different properties, which is obviously not the best thing. Okay, so right now we are either bidding or writing proposals for topics ranging from thesaurus management over semantic repositories to text analytics over cultural heritage data, and also another interesting area for me is manuscripts, medieval research. So there's a bunch of databases in medieval studies that could be integrated. That's an interesting. Okay, thanks for your time.